all of a sudden you look in your textbook and you see this. Binomial theorem. And as I was leaving class on Wednesday of last week, I think I had more students that I saw in the hall before I left saying, Professor, I enjoyed this one with the Pascal's triangle. That's what they were enjoying, the Pascal's triangle and the connection with what we were doing, which is nice. It's nice. But all of a sudden you see it described like this. Your textbook writes the binomial theorem out as this. X plus A raised to the n can be expressed as a summation where they want you to start out with j is equal to 0 up to n. N choose j, x raised to the n minus j, a raised to the j. Now, if I were a student and I have not seen you since Wednesday, and you walk in here today, Monday, and you see that for their so-called definition of a binomial theorem, you say, Professor, that doesn't look anything like what we're doing, does it? It sort of does, but I don't see a triangle. I don't see Pascal's triangle. Now, can I, and this way when you go off to a university, if you need more math in your university, you're going to have a textbook, probably online or something. That's what they're going to say. Refer to your textbook. I love professors in grad school or universities. Refer to your textbook. Refer to your textbook. And they don't sometimes give a direct answer. Refer to your textbook. Well, I've referred to the textbook. That's what it looks like. Then all of a sudden, Ignacio says this. Expand, knowing this, expand this binomial, and expand it, 2y subtract 3 raised to the 4th. The guys, listen carefully to what I want to hear, in case you see one of these on the exam. I want you, can you look back at their definition? Looks like this. And can you match things up with this?
Yeah.
And tell me what this would look like as a summation. So when I start filling in the missing parts, be very careful. I'll get you started. Definitely going to start with a 0 down here because they said start with a 0. Now the n at the top, 4. This, just like they did here. Now inside there it says n choose j. We talked about that last Wednesday. Guys, n choose j at this point, I'll sort of help you out. N is 4.
And then j.
J.
We're keeping
Hang on now. That takes care of that. Now, your textbook says in general they gave you a formula. They're calling it x raised to the n minus j. But if you look back at my expansion, the x they're actually talking about is what? The term. It's 2y. So they're saying now 2y raised to the 4 subtract j. And on the end it says now a, the last term, the way they have expressed your book here, is in my case
-3.
-3. So it's -3 raised to the j. Now, would I be happy if I asked you to do one of those for me on the final? Take that and just rewrite it using a summation. That's beautiful. Now, who on earth would think that this means this? Unless you had this reference here. Guys, you follow me? What's going on here? Now, I need to now expand this out. So we'll write the terms out. I may not go through all the terms with you because it's a little lengthy. Now, let's say that we'll start with j is equal to 0 and have what? 4 choose 0.
Equals
2y raised to the 4 minus 0, -3 raised to the 0. That's replacing j by 0. Now, if I follow what this summation means, now I'll replace j by 1. If I go back through, replace j by 1, this one now look like this. It's got to be patient. There's the next. Now j by 2. I replace J by 2, 4, choose 2. 2y raised to the 4, subtract 2. Negative 3 to the second. Okay, that was by 0, 1, 2, now by 3. 4, choose 3. 2y raised to the 4, subtract 3. Negative 3 raised to the third. You guys agree so far? Yes or no?
Yeah.
Okay, so I got 1, 2, 3, 4. I need one more term. That's replacing J by what? 4? So 4, choose 4. 2y raised to the 4, subtract 4. And a negative 3 raised to the 4th. Yes or no?
Yes.
I know it looks strange. And if you have not looked at this since last Wednesday, I know it looks maybe really strange. But that's the way it looks expanded out. Nathan, I'm not going to expand each one of these terms out or evaluate. I see 1, 2, let me circle those plus signs there so I can keep this straight. I actually have what, 5 terms altogether? Let's expand or look at the value for maybe a couple of these right quickly. Guys, I'm going to jump down to, let's try this one. I don't know what does that term really look like. And that's where you got to know your stuff. 4, choose 2. We had a formula last week. I think it's n choose j was n factorial over j factorial n minus j factorial. You saw that last Wednesday. Now if I apply that to 4, choose 2, guys, 4, choose 2 using that will be what? 4 factorial
Yeah.
over 2 factorial. And then of course the difference n subtract j, 4 subtract 2, another 2 in this case. Factorial. Now you gotta crunch it out.
We could take out 2.
Well, no, well, you could. Let me go ahead and do this since we have not seen this for a while. I know 4 factorial looks like that written out. In the bottom part, 2 factorial, I know it looks like this, 2 times 1. And of course I have another one right on the side there, 2 times 1 again.
Now, are those commas, or those,
Times, those are dots. Now, if I now do some canceling here, 2 into 4, maybe 2, lots of ways to do this. I can cancel this 2 with that 2, lots of ways to do it. Guys, do I end up with a 6? Yes or no?
Yeah. Yeah.
Is it 6?
Yeah.
Okay, so this is 6 for that part. Then next to it says 2y squared, which I can say that is what? 4y squared, yes or no? And the next to it says negative 3 squared, which is what? Is that a positive 9? I just found the values of each one of those parts. Are we okay? Oh, I see, it looks like, oh man, I should have looked at this before I came to class today. And then of course you finish it up. If this is all correct, I see, what is this, 24 times 9? Help me out, guys, that's 216, I'm doing it quickly.
Yeah.
Is it 216?
Yeah.
Y squared. And that would be, I just chose one of the 5 terms to show you that you can calculate each one of those terms by using what I did on this one term. And that's basically what we were doing last week. You guys who like Pascal's triangle, you could go to Pascal's triangle. I don't want to do that myself, but you can say, Professor, can I use this for a check? It's for a check. Let me put my numbers in here and see if I recall. You guys can help me. Okay, 0, 1, 2, 3, 4. Was this being raised to the 4th? It was. And I see the numbers here by Pascal's triangle should be 1, 4, 6, 4, 1. I think this was the term I was looking for earlier, wasn't it? And did we sure enough get a 6 or 6 times? I got you. A 6 here, out here.
Yeah.
Yeah, and we finished it up. Right? So we were doing a lot of good stuff on Wednesday of last week, but I thought I'd point that out. Strange. A beginning student look at that would be scared. What on earth is this? And this is what they call binomial theorem, and then we applied it to a particular problem. Okay, guys? Math induction. Flip it over. Before I leave and get into my chapter 9 here shortly. Math induction here, part 2, guys. I know it's done for you. Let me run through the proof for you. They want you to prove that this statement is always true. Jacob, do me a favor.
Yeah.
As I write this down, read the directions right above there.
Use mathematical induction to show the following statement is true for all positive integers.
Now he says all positive integers.
Z raised to the positive side.
Okay, there you go. Now this is where I've seen a few students mess up because it's a proof. Make sure that all that copied down correctly. Looks good. Now they want you to start replacing n by 1, n by 2, n by 3, n by 4, and it's supposed to go forever and show this statement is always true. So replace only by positive integers. Now I think I gave you guys steps to follow. I think I have the same steps there. Nathan, since you're close by, what was the first step? I'm not going to rewrite the words.
Step 1, show statement is true for n equals 1.
Now I may have that typed up for you. So you need not memorize the wording. I may have it typed up, show statement is true for n is equal to 1. Can't go wrong. That means the first term, 5, n is equal to 1, that should be equal to, on the other side, replacing n by 1. If not, you stop. I think though in this case, when I look at the right-hand side, I see 10 over 2. And I get a 5. Now I give you partial credit as you go along. So the first step of the induction proof has been satisfied. Okay, so that looks like my first student tested it for me, replace n by 1, and I'm good. It checks. Then I go to student number 2, try n is equal to 2 now. It's 3, then 4, and continue like that. Now remind the students how statement number 2, Nathan, reads.
Assume statement is true for n equals k.
Yeah, you gotta stop somewhere. We can't count forever. So up to a certain point, it's true. And we call that certain point k. So at n is equal to k, we're gonna write the statement as this. Going back to the original. I'm gonna replace n by k. And assume also on the other side, those n's are now k. And there's all you need to show me. That's it. Just show me it's true at k. Just go back to the original, replace all those n's by k. And I'm assuming that. Now here's where the work comes in. How's it worded, Nathan? The third step.
Show statement is true for n equals k plus 1.
Now you got one more. I call that k plus 1. Now what I do, and I'll draw this for you guys, they want you now to just rewrite step 2, which says it's true up to k. So 5 plus 8 plus 11, so forth and so on, up to this. You go back up and say, what do they want, Professor? They want me now to replace n by k plus 1. Extended. Let me put that in a different color just to show I am going to extend it. So step 2, rewritten. But now we'll extend it, replace n by 2, k plus 1 of me. That's going to look like this, plus 2. And that's the left-hand side. Right-hand side at k plus 1 looks like this. All those n being replaced by k plus 1. Squeeze that in. All over 2. First, guys, do you agree that's the extension? You take this statement here, rewrite it. This goes here, this is the black. And then you're going to extend it, we're going to add to it now k plus 1, which means replace this by k plus 1, k plus 1, k plus 1, and it looks like that. Do you guys agree? Now, if you can show those two sides are equal, we're done.
Isn't it?
Hang on, if we can't, but is this written up correctly?
Yes.
Okay, now. Okay. Is this equal to that? Guys, this much in the black, that's why I put this in a different color. All that, in an attempt to show the two sides are equal, back to step 2, all that's equivalent to this. So I can replace all that I just blocked off. That's the nice thing about induction proofs. I can replace all that with this. That's from step 2. But then I gotta add to it my extension here in the red. If I clean this up, guys, I see 3K plus 3 plus 2. Is that 3K plus 5?
Yep.
I'm adding 3K plus 5. The other side, we'll go ahead and clean it up. The other side over there, guys, in the red is K plus 1. This is 3K plus 3 plus 7. Looks like 3K plus 10. I'm getting scared. All over 2. Everyone with me? Now, if you can show that this side is equal to this side, we're finished. Proof is done. Can we tell me anything at all I could do maybe on the left in an attempt to show they are equal?
Common denominator.
Common denominator. Let's go to the black here. And by the way, as I start using my common denominator, would you mind if I go ahead and use the distributive property here?
Yeah.
So let's write that as 3K squared.
Plus 7K.
Okay.
Plus 6K.
Yeah, I'm gonna multiply by 2, 6K
Plus 10.
plus 10,
All over.
all over 2.
And then you can.
And I stick with that. You guys agree with that? Just combine the 2 with the common denominator 2. Right now, it's board space. Looks like it's 3K squared. Help me out, guys. Is it 3K squared? Plus what? 13K?
Yeah.
Plus what, 10?
Yeah.
All over 2. Now that's the left-hand side. Can I do anything else with it?
Can you package?
It looks like it might factor from algebra. I hope it does. And I'm gonna factor it, guys. I still over 2 here. Like this. I said you guys will agree. Will it factor into K plus 1 and 3K plus 10? Let me step back and look at it.
Yeah, I got it.
Does it factor into that?
Yes.
If it does it match up with this?
Yeah.
We're finished. The 2 sides match. Yes or no?
Yes.
So could we do an induction proof? Okay, so as soon as I see those 2 sides match up, I'm happy. All right.
Could you explain how the second statement, how do I know, like, I don't know why you say that it's correct.
This is an assumption. You're assuming that's true at some point K. In fact, in my description last Wednesday, I think I said, student number 1, please go to this statement, replace K by, N by, where was it? Over here. Replace N by 1 and show me it's true at 1. Then I went to student number 2 and said, please replace N by 2, show the 2 sides are equal. N by 3, and all the way through it, I say I have 22 students. Am I happy the proof is done? No. It says it's true for all positive integers. So now I need someone to test it for 23. Am I happy? No, 24. So it always goes 1 higher. So this is the assumption that this statement will be true at a certain point, up to a certain point, K. And then I show after that, it's true at K plus 1.
Oh.
Does that make sense? Yeah, this is the assumption. You guys show me it's true up to a certain point. We can't count forever. So somewhere we have just to assume it's true. I've already tested Professor 500 numbers here, and the 2 sides are equal. So where am I going to stop? Well, that K would be 500 in your case. That's what you're assuming. It's true up through 500. And then you guys show down here though, no, go further, it's also true at 1 more. That's where that K plus 1 comes in. Right? Okay. So guys, that's my little review. I gotta watch my time here tonight. No, I should have plenty of time. On what we were doing on Wednesday. This help? Okay? Really, a strange thing was this. So more than likely, I'll have this probably typed on the test for you. More than likely, I'll have the binomial theorem, just like I have in the textbook written, and ask you to use it and show me the expansion of one like I did here in class for an example. Yes?
Sorry, when we have like, expansion problem, would you have, like, for us, you have to calculate each one of those?
Oh, no, that may be too time consuming because you've got other things to do on that final exam. I may ask you now, just find one term for me.
Oh, okay.
Show me what, one term like I found this one, looks like. And nobody's gonna go through and evaluate all of them, it takes too much time. Okay, anything else? Isuji, have you guys used the binomial theorem in your Math 7 class at all?
I think so.
I don't, yeah. How about Math 8? Must be Math 11.
So it's not gonna be on the test,
Yeah, it must be Math 11. Okay, now it comes up sometimes. She's not meant for the 7 course yet, and he's not meant for the 8 course yet. Yeah, okay. Guys, anything here to worry about? Nah, just a quick glance at what we were doing. Now, part 3, I'm gonna squeeze in right here. Here we go. Let's see if I'm going to follow this handout. Oh, the induction proof is done for you on the back, looks nice. The conics. Now, I went to the math lab, I looked for the cone. I usually bring the cone in, and I think we all know what a cone looks like. And showed my class, which I don't know where that cone went, how to slice it. And as you slice the cone, you come up with sections as you slice pieces of the cone off. And each section is given a certain name, and it depends on how you slice the cone. So I know without even showing you the cone that I usually have, that if just a rough sketch, if I have a cone that looks something like this, let's put a little dimension to it here, something like this, and I slice this piece off here. I'm trying to think about it, that'll work. Yeah. What do you think, knowing that it's a 3-dimensional situation here, there's a cone, and I slice taking a plane, a flat surface. I wish I had the cone with me. Mr. Park, do me a favor, go down and see if Judith, check in the math lab and see if they may have it down there.
Oh, okay.
It's a wooden cone. But anyway, guys, the cone, and then you're going to slice it with the plane. And if I slice it right through like this, and it's a 3-dimensional object, slice it, goes through the board, and slices off, might you have an image, something like this, as you slice the tip off.
It's another form.
Which looks like it might be a circle. In fact, I think this base was supposed to be a circle here, my rough sketch. So it looks like, it depends on how you slice it. So that if you just slice off the tip, and then look at the image left over there, it's a circle. And I hope you find some kind of cone for you. So guys, each one of those depends upon how you slice. I gave you the 4 names. Now, am I gonna have time to go through each one as in depth as I wish to close the course down? No. I think I named the sections. Nathan, remind me, before he brings that cone back, hopefully, did I start out with one section of the cone? If you slice it with a plane, flat surface, was that a circle first? Okay. And I did not give you a standard equation for a circle. And usually they want the standard equation for each one of these conics. I left that out on purpose. Does anyone recall from middle school, what could you use for what's known as a standard equation for a circle with a certain radius and a certain center?
Y or X squared.
Hang on. Something else. Does anyone recall? I know it's been a long time since you've seen this.
X minus H.
Now they've already packed it up, moving into the new building. That's what it is. Does anyone recall? X minus H, they call it in most textbooks. X subtract H squared plus
Y.
K.
Subtract K squared equals
R squared. Where the H, K gives me the center, the coordinates of the center. So I'm gonna put a comma here. They ask you, where is the center of that circle, and you have it in this form, just read off H and K. That gives you the coordinates of the center. Radius, of course, that's radius there, that's what the R stands for. If you don't know what the radius is, it's R squared in the formula or equation, just take the square root, and you have the radius. Okay, so that's one we could end up with. Tell me now, since we don't have the code in front of us, Nathan, what was the next one's name? What else could I slice?
Parabola.
Parabola, hang on. Hang on a second. Right now, I would think if you slice that cone, and depends on how you slice it, probably sideways, and you get a parabola after you slice it on the side of the cone. Does anyone think they might recognize an equation for a parabola? We got the equation for the circle. Go for it. Okay, f x or this is called y.
Oh, sorry, y equals
That
x.
could be f of x though.
X, or a, x, or I know there'd technically be b, but x minus h squared plus k.
Thank you, Jacob. You saw that in this class. You remember doing this? In fact, I think way back when you start reviewing your exams for the final exam, I asked you to do this on one of the tests where you had to complete the square and put it in this form. And then check it probably using what? Negative b over 2a. That's what they're talking about here. By the way, guys, this thing has a vertex. Not a center here, they call it a vertex. And you could use what? Negative b over 2a. We'll find it quickly. Does anyone recall how to find the second coordinate of that turning point called the vertex way back in the previous chapter? What did we do to find the second coordinate, the y
B
coordinate?
minus 4ac.
Yeah, there was something like a crazy thing, 4ac minus b squared over 4a. We prefer to do this. Go back to the function.
And then just plug it back in.
Absolutely.
F of b, negative b over.
Absolutely. Okay. Now, have we done this? Jacob just gave, we've done this in this class. And Nathan, I recall maybe we worked a few application problems where they ask you the height of a ball thrown up in the air, find the highest height, and how much time it takes to get there, things like that can be applied here. Now you're gonna be shocked when in chapter 9, they give you another form for the parabola that you haven't seen. Now this one will give you the vertex. Okay, the others will give you something else. We're going to take a look at it shortly. Now, Nathan, you're close by. Read the definition for a parabola. And we're going to see.
A parabola is the set of all points in the plane equidistant from a fixed point, focus, and a fixed point or a fixed line, directrix.
Now, I heard a couple of words I don't think I've ever used in this class, except to tell Austin to focus. I heard that focus there, right? Yeah, or tell my students, focus. No, they want focus in terms of a parabola. What is it? Read that to me one more time, a little slower. I'll say that for you.
A parabola is the
Not that slow, not that slow.
set of all points in the plane equidistant from a fixed point or focus and a fixed line, directrix.
Here we go. He's telling me by this new definition. Go to a grid. And say, Professor, I know the entire class knows what a parabola. I don't have one that curves like this. What a parabola looks like. Pick up just a basic one. Now he tells me something that we have not noticed was this thing has a vertex. It opens up. We knew that way back. But his definition says, hold on, the true math definition for a parabola says there should be something called a focus in there. And something called a line called a directrix. To make this parabola take the shape you see it taking. All you guys know right now is the vertex. what we worked with in this class, maybe the axis of symmetry. But he said, no, Professor, hold on, they're saying, I'm placed right here for a reason. I'm gonna place something called the focus there. Guys want to label this with coordinates of, since it's on the y-axis, 0, and I'm using A. You can use whatever you wish. So the coordinates for that focus that he's talking about from the definition, 0A. Now he tells you, hold on, Professor, the distance from, let's say, from here to here on that parabola, now you got to measure on the opposite side, same distance, and draw a line. Okay, draw a straight line, same distance. And mine, I'm gonna try to make it look like this, if I can. And let's do this. And that's what he has named for me in that definition as a directrix. So guys, again, mine's not drawing to scale. This distance to the focus should be the same distance down to the directrix. If that distance is not the same, you will not get that curve known as a parabola. So for every point, which there's an infinite number of points on that parabola, it's got to be true. When you measure to the focus, when you measure down to the directrix, they had better be the same, or that shape will not be as we expect. Guys, making sense of that so far? Now we'll do this to sort of develop an equation for this. Guys, I'm gonna place a point on, place it over here somewhere. Place it here, I'm gonna extend my parabola up. And let's make it look reasonable. Let's say a point is right here. And this point is on the parabola. We'll call it XY. And I measure over to the focus from that point. I'm trying to make it look as reasonable as I can. Go from the focus to here. And find that distance. Now, if this is a true parabola, that curved parabola, then when I measure from here down to my directrix, I'm going to change my directrix to make it look more reasonable, it should be the same distance down to that line called a directrix. Let me straighten this up just a little bit here. If not, Matthew, if not, if these two are the same length, you're not on a parabola. That's by definition. You measure to the focus, you measure down to the directrix, you make them equal, they should be equal, then you have a parabola. Laura, if there's a point on there that you measure over to the focus, down to the directrix, and those two distances are not equal, you're not on a parabola. Okay, so each one of those points must satisfy that to form this curve. Guys, you follow the logic from what you read there? Now, what I need to do is to express the distance. I know there's one point down here. And guys, it looks like I'm using A here. I went from here to here and I call that A. What would be a nice name for that directrix, that straight line down there? What would be a nice name for it? Because I'm using A for the distance. What would be a nice name for that line down here? Y, it's gonna be a Y, it's a horizontal line.
Well, I minus negative.
Negative A?
Negative eight, yeah.
That's right, I heard that, okay. Now, with that said, can anyone tell me, then we'll start this work here. Can anyone tell me, what on earth could I label for coordinates for this point right here? Because I need it in my derivation.
X.
X for short, because it lines up vertically with the point right above it. The other? Negative A.
Negative A.
That's the Y. Okay, now can I go through a derivation for the other remaining conics tonight? I doubt it. I wanna make sure you understand there's a derivation required here. Now, what's gonna happen here, I think when he read it to me, he says those two distances, Professor, must be the same, must be equal. So I need to express the distance from here to here, let's call this point B. And from B down to point C. So in other words, the distance from F out to B, it's gotta be the same as B down to C. From that definition that he read to me. Does anyone think they remember how to find the distance from here, this point to this point, F to B? What may be required that maybe we have not used for a while?
Y
What?
Isn't it Y1 or X1 minus?
Tell me more though.
Right, X1 minus X2 over Y1 minus Y2.
Close. And we haven't on this class used it very often, but I need it now. I need to express the distance from this point here on the parabola to this focal point or focus. I need the distance formula. Now, I spent a long time. The distance formula, D is equal to square root, I'm gonna call this x1 subtract x2 squared. After this plus y1 subtract y2 squared. That's the distance formula. All I need to do is replace in that distance formula my coordinates. And guys, I'm gonna write my distance here, and this is from F to B. The focus to that point should be square root of x1 minus x2. I'm gonna write that minus x subtract 0.
X squared.
Okay, just x squared. I'm writing that x subtract 0 first. Absolutely awesome, and it's merely x squared. And then y1 subtract y2 will be what? Y subtract a, the way it's labeled, squared. That's the distance between those 2 points by using the old standard distance formula. Now the other distance, it goes from B down to C. This one's done, but this is number 1. Now number 2, I'm interested in this length, B to C. I can apply the distance formula again, if I wish, from here to here. And if you did, on the side here, if you could, it's square root of, same distance formula, x subtract x, that's interesting, squared, plus looks like y subtract a negative a. Is that true, guys? Y subtract a negative a, this subtract this for the distance formula?
Yeah.
Which turns into what? Y plus a, that's being squared. Definitely. This class needs to see the derivation. We're going to work over here, and we'll see how all this works out. Okay, guys, FB should be equal to BC. So set this equal to this. Nathan, this is what you read for us. FB, if I cleaned up a little bit, just a little bit, square root of x squared plus y subtract a squared. That should be equal to, by definition, this. This brings up nicer. The x's cancel, that's 0. So I actually end up with square root of y plus a squared. In fact, I can even call that something. Guys, this drops out, which is nice on this one, from B to C. And then I have what, just square root of what? Y plus a squared, could I just call that y plus a?
Yeah.
Perfect square root, which we lucked out. And it looks like that. At this point. Now they want you to clean that up. Now first of all, let me slow down and make sure what Nathan read to me. Does it make sense the way I'm gonna sketch there? I'm saying 2 distances the same. It must be equal. Guys, if we want to go further and clean this up, I think most students would say, Professor, why don't I do this? Get rid of that square root. Let me take my time here. And of course, the other side, guys, y squared plus, be careful,
2YA. plus
thank
A
you,
squared.
plus a squared,
Yep,
absolutely.
you couldn't even do.
Now, can I do the same thing here?
Yeah,
So that's why
I
this is,
mean, not the same, but yeah.
well, I'm gonna expand it. So this is y squared minus
Two
2ay plus a squared, I'm gonna rewrite. It's equal to this. And if I step back and look at it, now it looks good, I think. Now, can I clean it up further? Yes, I think I see some terms canceling out. These cancel, I think. A squareds cancel, I think. Start to say the two AYs cancel, I don't think they do.
No, you have to combine the.
Thank you.
So then
Move
you
this
get
over.
X squared,
X squared is equal to, combine those AYs, what is that, 4?
yeah, AY.
AY. Here's the professor, are you kidding? That's another equation besides the one back in middle school, where, here. Besides this black one here that I'm so used to in this class in middle school, are you telling me that's another formula, equation, that textbooks will use sometimes for a parabola? If I see that, professor, it's gonna graph into a parabola. If you see an equation that looks like this, Ignacio, it's gonna be a parabola. If you see one like this from middle school, it's gonna be a parabola. Laura, why on earth do you think, before I get into the details here, would they in chapter 9 say, let's do this and rewrite or have another form? What does this tell me right here that maybe the middle school equation would not tell me? They must have a reason for another equation. And I'm gonna remind you, this one tells you where the vertex is, and it tells you whether it's gonna open up or down. We went through all that in this class. Now what's this one tell you right here? Or could I play with it and find something that maybe the one from middle school does not tell me? Jacob, go for it.
Wouldn't it tell you where the focus?
Now, he says, Professor, maybe since you use the word focus and directrix, maybe this one, I can play around with it and find where the focus is for this parabola, which I could not the middle school. And then the directrix. By the way, just out of curiosity, does anyone think they know where the turning point vertex might be the way this thing looks? Even though I don't have it in this form here. Can you give me a guess where do you think the vertex might be for that?
0.
I think it's at the origin, 0, 0. I don't see any shifts taking place here. So, hang on. So it looks like a 0, 0. Now, Jacob's saying, Professor, I think, first, if I want to look at this, okay, Jacob, here goes. Let's try on the side here. And guys, I think I have one on the handout there. I think. I do. X squared is equal to 8y. That's all you see. Anyway, Professor, does this right here, does this resemble this?
Yeah.
Somewhat. So I might think, oh, look, the equations look very similar. So I would think, Professor, you said this is going to graph into a parabola. This is going to graph into a parabola. It does graph into a parabola. Now, if you want to rewrite like this, which I really do not need at this point, that might tell you that the vertex is short of 0, 0. So I got parabola with vertex 0, 0. Now, what's missing is, for today, where is that thing called focus, Professor? And before I find it, and directrix, now you know what this reminds me of? Like a satellite dish. Beaming. And I guarantee you, there's a point inside here. I'm calling this the focus. Somewhat like a flashlight. Where the little bulb is located. Right in there somewhere, like a satellite dish. With that curvature. And inside there is that point they call the focus. We need to find the focus of this particular parabola. Now see, hands going up here. Matthew, let me get you started here. Matthew, I'm trying this. It does not quite match up with this, but it's got to match up. I've got to make it look like this. Can you tell the class, I'm gonna do a little here, hang on, what you might make this look like? Make it take that form.
You can make it x squared is equal to 4, replace a with 2, y.
Wow, hang on, let me put that in different color. You're saying put a 2 in here for the A. Close that up. Y. Look how clever he is. Now this looks like this. And what's that A right there? That A is gonna tell me where that, what was it? Focus is located.
On directrix.
You could not find that. In fact, I don't think these middle schools even mention focus and directrix. And they do parabolas. They're very happy that you do a vertex. I'm sure teachers are celebrating you just do a vertex. They have, maybe some teachers don't realize there's a focus and a directrix also here. Yeah.
Couldn't you use this form with a vertex that isn't at 0, 0?
Oh yeah, of course, I'm gonna show you one. It's been shifted. This was not shifted
That's
here.
just without that.
Yeah, absolutely. Guys, if I want to graph this, and thank you, Matthew. If I want to graph this, I'll make a quick sketch of this. This one does have a vertex at 0, 0. And you'll say, well, Professor, if everything works out the way it looks, no shifts here. You're saying the vertex is right here. Austin, all I'm gonna do is, this is vertex, 0, 0. I'm gonna use this 2 here. And by the way, guys, would you recognize that this, the way it looks, would be a parabola opening up? Okay, and if it opens up, and I'm know where the focus is, it says move up 2 from that vertex. Got it? If I go up 2, I'm here. Right here is my focus. I'm gonna label it as 0, 2. Where's my directrix? It should be on the other side, same distance. So let's drop down to -2. And this is gonna be your directrix. And I'll label this as y is equal to -2. There's your focus, there's your directrix. Not drawn to scale. You may say, well, Professor, that means it's gonna look something like that. With the focus caught inside and the directrix on the other side. You guys agree? Okay, now who on earth would think? I wouldn't as a student. I probably didn't see this till way but later on in my math, because most teachers just focus on vertex, vertex form, vertex form, vertex form, negative b over 2a. Who on earth would think that a parabola also has a focus and a directrix?
Maybe it counts.
Okay, now we know there is one to make that shape take place. Guys, any concerns here? Now I'm looking at, I'm watching my time here. Did I have one more here? Oh, I did have a number 2 here. Nathan,
Yep.
let me do this. That may be where I want to stop for right now. What was example number 2? I think I just turned around a little bit. Was it y squared is equal to 4,
Y squared is equal to 8x.
8x? Then we're gonna sketch this one before the break comes up. My goodness. And what I'm gonna do is, Jacob suggested earlier, can I rewrite this right quickly as y squared is equal to, now I notice this one says x squared, so turn around a little bit, but I still need that 4, the form. So 4 times again, as Matthew gave me, a 2 earlier, still 2 here. X. And then I need to sketch it. Now, can anyone tell me, this is the reason I put this on here, we're sketching this time. Last time we sketched this one, make it up look like this. The way this one looks, can anyone give me an idea of what might be happening here?
Might be like sideways.
Sideways. It's not gonna be a
It'll be
vertical
opening to the right.
parabola, it's gonna be opening either to the left or to the right, or horizontal. Guys, if I do that, with the knowledge of my vertex is still at 0, 0. It's gonna open sideways. Is it gonna open to the left or to the right? What do you think? To the right. So it's going up to the right. So I need the focus, and the focus says, please move out, here's that magic number again, move out 2 units to the right in this case. In other words, you're on the x-axis, you're right there. This is my focus. Coordinates 2, 0. The directrix should be on the other side. If it is, I need to go over to -2 in this direction. And this time the directrix for a line is a vertical line, not a horizontal. Draw the graph. Something like this maybe. Not drawn to scale, but we're saying the distance from here to here should be the same as the distance from here to here. That makes that curvature for us. So guys, got the focus already labeled for you. The directrix, by the way, would be labeled as x is equal to, not y, this is the vertical line. X is equal to -2. Susan, you were telling me in the office the other day that you guys had a conic in your Math 7. Was it a parabola? And was it, she had this just the other day, she was telling me in Math 7, they did some calculus with it. Was it one of these that opened sideways? Yes. Did you guys have to find the focus and directrix? Was that mentioned in what you had to do with it or not?
No, we just had to sketch it.
Just had to sketch it.
And find the area.
Now, she's telling me, after you sketch this, I'm going to the Math 7 now before I leave this. This is beautiful. Let's take a look at that blue graph there. Laura, she's telling me when you reach Math 7, this is what you do next. That teacher, it might be me, does this. Okay, here's your graph. I'll say, okay, now revolve this around that axis. Revolve it around the axis. Nathan, I'm talking about the x-axis. If I revolve it, might you think you might get a curve that might look something like that?
Oh, like it's going like
Like
this?
it's going to be being
Okay.
revolved around the x-axis. Might you think you might get something like that? That's a solid. That's a three-dimensional figure. And then she's telling me they probably, did you guys find volume of that?
Yes.
They find volume.
Very.
Yeah, how much would this thing hold? This is what it's all about.
So are you like adding a z-axis to that?
No, we're not going to a three-dimensional there right now. Yeah, you would have to then, yes. I'm just
Okay.
pointing out what to expect. Okay, guys, so you get the solid, and then we're going to ask you how much water would that solid now hold that you just formed with the help of that parabola. That looks cute. Until you start the calculus on it. Yes?
Within like, what would the practical
This is like a
application
satellite for
be?
sure.
So
Like a satellite dish.
The creation of satellite dishes?
Yeah,
or-
yeah. Now, I don't know exactly, Susan, you may not remember, you guys were asked to find the volume, I guess, of this. And then he gave his class techniques of finding disk method.
Yes.
Yeah.
Shell.
Okay. I think there was another one, besides
Shell.
disk, the other was what?
Shell.
The shell method. You guys will see that later on, not right now. Now, did I have one more there to do? Yes, I think I did. Oh, 2 more. I may do one more. I want to do one that has a shift to it. I'm checking my time here. Beautiful, I can do it. Now, the one that has a shift to it is, and by the way, guys, was the last one the one I had handwritten in?
Yeah.
Okay, remind me what it says, Nathan.
X squared minus 4x.
X squared
No,
equal,
that's
the
not
last, the
one.
last.
Oh, the
Yeah.
x squared is equal to -12y.
Now, if you have a negative there, and I know right now, you got x squared, Nathan, is equal to -12y, I think. You said, Professor, if I want to put it in this form you're talking about tonight, could I write this as 4? I need the 4 for sure. There you go. -3, y. Is that true?
Yeah.
Yeah.
Now, this is gonna be a parabola, the way it looks, one that you're accustomed to, it's gonna open vertically. It's not gonna be a sideways. Does anyone see what difference is it? How can I tell so quickly, is it gonna be a sideways, horizontal parabola, or is it gonna be a vertical?
So vertical.
Depends on what's being squared.
Yeah, if it's
If
x
the y is being squared, it's gonna be what, a vertical? If the x is being squared, on this one, where was it? Down here, I think we did this one down here, this was a vertical here. This is gonna be a what? Horizontal. Is that true? Let's
Yeah.
look at it. Now, whoo, lots to do here before I finish up. Tell me guys the difference. Let me go back to where it was here. This is gonna be a vertical here, right? Is that true, guys?
Yeah.
Vertical? What might the negative sign do that
It'll flip
the
the
earlier
parabola.
vertical did not do for me? My vertical looked like this.
It'll flip the
Go
parabola
face down.
the direction.
That's all the negative sign does, it's gonna be like a reflection through the x-axis, it's gonna be upside down. So I'm not gonna do that one. I will do this much for you. That 3 tells me now how to place or find the focus. 3 units up, 3 units down, and how to find the directrix. Okay? No problem there. We're about to finish the parabola up. Nathan?
Yeah.
Here's where we'll finish. Please tell me, I have a handout right in front of me, but I want you to read it to me. What does the one that looks a little lengthy look like?
X squared minus 4x is equal to 8y minus 28.
Oh my goodness. And we're gonna take a break after this. Now, real quickly, we realize this is gonna be a parabola.
Mhm.
Now, is it gonna be a horizontal that opens to the left or to the right, or is it gonna be a vertical?
Up and down.
Vertical, up or down. In fact, the way it looks, it might be opening up
Yeah.
at this point.
Yeah.
Trouble is, if I'm trying to put it in this form we're talking about today, what might be the trouble?
You gotta complete your square.
I've got to complete the square. This one's a little bit lengthier than the others. So if I do this, and remind you how to complete the square on the x's, guys, that number, I'll put it on both sides. I have to complete the square on this. And the completion of the square, I think we thought, what, take half this number and square it? I think that's the way we did completion of the square. We're gonna do 4, of course, we gotta add each side. So I'm gonna end up with x subtract 2 quantity squared, looks better. And down here, you're gonna end up with 8y subtract 24. Even better?
Take the 8 out.
Absolutely. Take the 8 out. We write this as y subtract 3. And to make it fit the form we're talking about tonight, right, that's what, 4 times 2?
Yeah.
In the bracket. Now, Laura, this one, the last one I'm doing, this one, the vertex is not 0, 0. There's some shifts taking place. Looks like you're shifted what, 2 to the right?
Yeah.
And probably, be careful here.
3 down. 3 down. 3 down.
Okay,
There's a 3 up.
hang on now. You'd be out 2, up 3?
Yeah.
Is what you guys think is out 2, up 3?
Yeah.
I'm gonna ask you this, here's another way to think about it in terms of shifting. I know for sure this is a horizontal shift. Looks like from way back on transformations we did here. Guys, what replacement could I put here to get back to my 0 that I had the others to be? A 2. Here, a 3. So my coordinates are 2, 3. That's the vertex of this parabola. That will take me back to 0, 0 that we started out with. So I want to sketch this real quickly. Quickly. Out 2, up 3. Place it right here. This is the vertex. It's going to open up, and it looks like that 2 is trying to tell me something. Well, I go to the vertex and it go what? Up 2, and then drop down 2, is that true?
Yeah.
And that'll give me the focus and the directrix. Guys, when I move up 2, that's gonna take me up to, I think, 5. Place that right here. And name this as the focus 2, 5. Go back to my vertex and drop down 2. I'll be at, what, 1 is it? And this is gonna be my directrix. I'll label this as y is equal to 1. Fatima, I got a rough sketch here. The distance from here to here is supposed to be the same as the distance from here to here. That equal distance, they call it. Are we okay, guys? Then draw the parabola. And it might look something like this. That's all the information gives to me.
And are we like writing down any intersections?
Beautiful. I love that, because that's where I'm beginning tonight. Mr. Professor, it looks so easy when you do it, just move up 2, drop down 2. Focus directrix. What on earth, if you give me one of these on the test, I'll get that correct, sure. Now, Nathan, being curious, he said, wait, Professor, that parabola looks like it's gonna have a y-intercept. Looks like it's gonna intersect the y-axis, not the x. So if I ask you to find the specific y-intercept in addition to what you've already done, we know where the focus is, we know where the directrix, the y-intercept, now stop here. You know how to find the y-intercept, you do what?
Just throw X in 0.
All these x's are 0, look at that, that's gonna make this side 0. You're left with what, 8y subtract 28. Solve that from across the street. And I guess you will end up with 3 and something. Is that 3 1/2? I did that quickly. Is it 3 1/2? I think it is. Is that true? Is it 3 1/2? Yes or no?
Yes.
Yeah.
Couldn't you also just plug it into the?
Okay,
other-
now, with that arithmetic done, 3 1/2, can we now say, Professor, you could? You made a quick sketch in your discussion. That was discussion, Austin. 3 1/2 missing. Can you now make it a little better? A little wider here, and go out more like that. And make it look like it's gonna intersect the y-axis in a reasonable place now. Of course you can. After you find the y-intercept. So good, I'm glad you brought that up. We did find the y-intercept. So, absolutely. Jacob.
You also not replaced x is 0 in the equation, x minus 2 equals, or x minus 2 squared equals.
Oh, here. Of course you could.
Okay.
Of course you could. Replace x with minus 0 in that form. You get the same answer. Guys, how's that look? Took a little bit more time, but what absorbed my time was that little recap on the binomial theorem and the others. Now, as I've said many times before we take a break here, I could not have done this without the help of my 2 assistants. Now, these guys have gone over and beyond their responsibilities. So you guys who are taking advantage of them, just remember they went over and beyond the call of duty there. I saw scores improve after we started working with the assistants, and all of a sudden I see a quiz score go up, an exam score go up, beautiful scores going up. Mr. Park, are you guys going to do anything? I'm gonna be here Wednesday. Their test is Monday, next Monday. You guys got anything planned for, besides me, on Wednesday for a review?
All weekend, right?
I was gonna
All week, a weekend?
Yeah.
I was gonna be at the math lab at Monday to 11 to what was the test?
The
time?
test starts at 3:30.
11 to 3:30, and at Friday I might be at.
No, I'm talking about Monday of the test. You're gonna be here Friday of this week.
So I'll be at Friday and Monday, both.
Are you gonna be here on the exam day also, next Monday?
Yeah,
Okay. In the math lab?
in the math lab.
Okay.
Yeah.
Now, guys, I will not be here Monday. Not for that 4 o'clock session we usually have. Those sessions are over. I hope you enjoyed them. I'll be here Wednesday, from 4 to 7 for my review. But Monday, unless you catch me in my office doing some work, I've got tons of work I gotta do. I'm not there at 4 to 4:45 for the usual review session, that's done. Okay, so your test starts at 3:30 in fact. So I can't be there at 4 o'clock. Now, before my assistants leave, go ahead.
Will we have tests on Monday or Wednesday?
Your test is on Monday.
Monday
Monday.
at 3:30.
Okay.
Yeah, it was sent out by email, you got it on campus. Now, whew, when I score these, I know students are on edge when they take a test. And I'll try to get the scores in as fast as I can. So we don't know what grade that is, whether or not you had to repeat the course, whether or not you did not have to repeat the course, but maybe you did not get the grade that you were hoping you could get, but at least you got a C, maybe. Let's hope that we get higher grades than that though. But I'll get everything scored, put it into Canvas, and Canvas will tell you your percent, and then I'll transfer that into a letter grade. But Canvas is one that'll give the grade to you, the percent. And then I just say, that's a C, that's a D, that's a fail, whatever it comes out to be. Now, before I take a break here, my assistants. I love these guys. I had these guys in class. Have a little gift.
Aww.
Susan, I think maybe this